Keeper 1.1 is on analyzing categorical data. As we saw in Keeper 1.0, categorical variables place individuals into one of several groups of categories. In this case, the individuals are the radio stations, and the variables being measured is the kind of programming that each station broadcasts. The table to the left, which we call a frequency table, displays the counts or frequencies of stations in each format category. On the right, we have a relative frequency table, which shows the percent or relative frequencies of stations in each format category. So again, the difference between the two tables is that the table to the left, your frequency table, shows the counts, whereas the table to the right, your relative frequency table, shows your percents. Sometimes it's kind of hard to read a frequency table. It's kind of hard to see what it's really trying to tell you. So instead, we'll use bar graphs or pie charts to analyze the data. A bar graph represents each category as a bar. The heights show the category's counts or percents. Bar graphs are really easy to read, and they're really easy to make. Pie charts show the distribution of categorical variables as a pie whose slices are sized by the counts or percents for the categories. A pie chart is made up of a whole, so you have to show each category that make that whole. Pie charts are often very hard to make by hand. Be careful when making bar graphs. You want to make sure that the area or the width of your bars are equal. A lot of times when people see unequal bar widths, they are under the impression that one bar is bigger than the other instead of looking at just the height. So you want to make sure that your widths of each bar are exactly the same. Not only that, you don't want to use pictures when making your bar graphs. They're oftentimes misleading, and they can confuse the audience or confuse the reader. So for example, this was the ad that we found from DirecTV that shows how much better they are than the competition. Well, there's a lot of issues with this. Number one, the heights of the bars. So you see let's go from 56 to 81, you see that height. The difference in height is very small versus the difference from 81 to 95. That height is much bigger. So not only are they being deceiving by the heights of the graphs, but they're also being deceiving by the width. So you see the width for cable is fairly small. It gets a little bit bigger for a dish. And then when you go to DirecTV, the width of this bar is huge. It makes the audience or the person watching the commercial or reading the commercial, it makes them feel like DirecTV is so much greater than the others, when truth be told, obviously it is a little bit higher. You're getting more channels, but it's not so much as they're trying to make you believe. So you really want to be careful when you're using graphs that have pictures and graphs that have unequal widths of their bars. Now, sometimes we want to analyze two categorical variables. We don't want to look at just one variable. We want to look at two, and we want to see how they act and how they can be compared to each other. But when we want to analyze two categorical variables, we'll always create a two-way table. The two-way table is designed to analyze these two categorical variables by organizing your data into rows and columns. So here we're looking at young adults by gender and chance of getting rich. The variables that we're looking at, the two variables, is your gender, and then the other variable is your chance of getting rich. So if you see, our gender is up here across the top, and our chance of getting rich is along the side. There were a total of 4,826 adults surveyed in this example. A marginal distribution is basically the distribution of your totals. It's your total categories, the total amount of males, the total amount of females, the total amount of whatever. That's your marginal distribution. The way I remember it is that your marginal distribution is in the margins of your tables. It's along the outside. It's your total columns. Now, not all two-way tables will have a total column, but you can always include a total column by adding up the values inside of the table. Keep in mind that percents are more often more informative than counts. The percents help you when you're analyzing different groups of different sizes. It lets you know, it actually allows you to compare the two groups even though they are of different sizes. So when you're looking at your marginal distribution, you want to, again, use the data from the total columns in percents, not as counts. You want to change them to percents, and you want to look at those total columns to make a graph of your marginal distribution. That graph will give you information of the totals of your data. So here, using the same example of young adults by gender and chances of getting rich, we're looking at our marginal distribution. Now again, your marginal distribution is your totals. All right, I'm not looking at each individual element. I'm simply looking at your totals. So in order to take these, because again, these are counts and we don't want counts, we want percents. So in order to get that, we're going to take our totals. For instance, our total of almost no chance of being rich, our total is 194. That's a count. To get it to a percent, I'm going to do 194 and I'm going to divide it by the grand total of 4,826. So here we see I took the 194 divided by 4,826 to get a 4% chance of almost, or a 4% value of almost no chance of being rich. Now again, that 4% represents all males and females who felt that way. All right, it's the total amount of people who felt that way, who felt that they had almost no chance of being rich. And we do that for each one of our values for chance of being rich. So almost no chance, 4%, some chance, 14.8, 50-50, 29.3, and so on and so forth. Again, this is our marginal distribution. The second I do this and I make it into percents, now we have our marginal distribution. And what's nice is we can take our marginal distribution and we can create a graph, for instance, a bar graph, to look at how the different distributions or how the different values of the variables compare. So, for instance, I see that people felt they had a 50-50% chance and a good chance. That was pretty much equal amongst the males and the females being surveyed in this data set. Now keep in mind, marginal distributions tells us nothing about the relationship between the two variables. It tells us about the totals. So even though I calculated the marginal distribution, it didn't tell me how males compared to females or vice versa. It just told me about the total amount of people that were surveyed in general. If we want to figure out, or if we want to analyze the relationship between the two variables, we need to look at a conditional distribution. A conditional distribution will allow you to analyze the relationship between the males and the females, or whatever variables you're looking at. To properly examine or compare conditional distributions, you want to determine what row or column you're looking at or what you're interested in. You want to calculate those conditional distributions as percents. Just like with the marginals, you want to change them into percents. And then again, you would make your graph to help you display your data. For conditional distributions, we generally use a side-by-side bar graph, or we can use a segmented bar graph. Side-by-sides are, again, a lot easier to make, but you do need to know how to make both a side-by-side and a segmented bar graph. So again, same example, we have our young adults by gender and chance of getting rich. We want to calculate our conditional distributions of opinions amongst males. And then I want to look at the relationship between gender and opinion. So for conditional, again, first part, I'm just looking at males. I don't really care about this grand total. I don't really care about females. I'm just solely focused on males. And so for males, I want to get all of my opinions, almost no chance, some chance, 50% chance, good chance, and almost certain. So I want to take it just for the males, which in the first case, almost no chances, just 98 males said they had almost no chance of getting rich. And instead of dividing it out by the grand total, since I'm only focused on males, I'm going to divide it out by the male total to get my percent. So I'm going to take 98 and I'm going to divide it by 2459 to get a 4% value of how many males say they have almost no chance of getting rich. I'll do that for each one. So again, some chance, I would say 286 out of 2,459, which is 11.6% of males said they had some chance of getting rich. From there, I would create my bar graph to see the male's opinions of their chance of getting rich. Now, once I do the males, if I want to analyze or compare gender, males and females, I would then do the same thing for the females. So I would do like 96 divided by 2,367, 426 divided by 2,367 to get my percents for my females, and I would add it to my graph. This is what we call a side-by-side bar graph. Now, a couple things I want you to note, and which is very, very important for when you go to take your AP exam. Every single graph that you make, you have to include a title. So you see here I have the title, Chance of Being Wealthy by Age 30. We have to label our graphs. So on my left-hand side, I have my percents. On the bottom, I have my opinions, and then I actually put in what opinions they were, almost no chance, some chance, and so on. And then not only that, I had to have my key, which shows that males is in blue and females is in red. You have to include that for every single graph to make sure that people know what you're talking about and people are able to read your graph without, any commentary or any type of help. They should be able to just look at the graph and see what you're talking about. A side-by-side bar graph allows you to analyze the two variables by looking at the heights of the bars. So for instance, good chance, I see here that more males believe they had a good chance of being rich than females, and vice versa. Down here we see that more females believe they had some chance than males. As well, you can see that for almost no chance, that's about even. Both groups, about 4% of both groups said they had almost no chance of being rich. Now, instead of a side-by-side bar graph, we could have also made a segmented bar graph. The segmented bar graph tells us the same thing. It's not that hard to make, but it is a little bit harder to analyze and see and compare. But basically how you make your segmented bar graph, you go up by your values. So we have 5 different colors here. The 5 different colors are your chance of being rich. So for instance, this light blue is almost certain, purple is a good chance, and so on and so forth. So when I go to make my males, I started with almost no chance, which was 4%. So I colored blue 4% of the way up. Then for some chance, we had 11.6, so I added 11.6 more onto that and colored that red. So by this part, this line right here, I should be at 15.6 because I did 4 here and then 11.6, that totals of 15.6. And I keep adding it up, all the way up, until I get to the very top. Your top of your segmented bar graph should always be 100%, because if you add all these up, you should be at 100%. Alright, so as we go further in this class and as we move on to more harder problems, even in the later chapters, we'll always use a 4-step process to answer and analyze our statistical problems. The first step is to state your problem. You always want to state what question you're trying to answer. It could be something really small, it could be something really big, but you always want to go ahead and state what you're trying to answer. Then you want to plan it out. How am I going to answer the question? Now, this isn't a plan that you do in your head. This is not something that, I planned it in my head, Miss D. That's not how it works. You want to plan it out, and you're actually writing it down. And you're writing it down in a strategic way. It's not just you're throwing something on paper. Everything has a process. So you state your plan. You state what question you're trying to answer, and then you want to go ahead and plan it out. And also when you're planning it out, you want to say how you're going to do it, like what statistical methods or techniques you're going to use to try to answer the question or answer the problem. So after you state it, after you plan it, then you actually want to do it. You want to make your graphs. We always use a lot of graphs. And then you want to carry out any calculations that you need to. And lastly, you want to conclude your findings. You don't just give the data and don't say anything about it. You always want to give some sort of conclusion when you're done doing your data analysis.